All right, so we're gonna go over, I'm repeating this for you guys. I'm gonna go over the bottom of page 35. The first one was really easy. Just do 24 with a difference of 2. Bring your fingers together. You got a dew point of 21. Question 2 was slightly different because they gave you the wet bulb depression, which they told you is just the difference between the wet and the dry bulb. So this was actually even easier. They told you the dry bulb was 20. They told you the difference was 6. You should have got a relative humidity of 51. All right, now the next one is a little trickier, but it's just like some of the ones we did up here. You got to work with what they give you. So they want to know what is the relative humidity. In the end, we're looking for relative humidity, but they only told you the dew point and the wet bulb depression. So again, remember, wet bulb depression is the difference. So you work with what they gave you. They give you the dew point. So you got to go up here. They give you a difference of 1, a dew point of 6. So that happens right here when the dry bulb is 8. Is 8 the answer? No, because what did the question want? Go back to the question for question 3. What were they looking for? Relative humidity. So now I know it's a difference of 1, a dry bulb of 8. You should have got 87. All right, the same idea here. So they give you, they want to know what is the dew point temperature. If you did 86, so what you did is you did 1 and 6 and got 86. But remember, the difference was 8, and we figured that out from up here. So that actually, and honestly, on my first answer sheet, I also did that mistake. So don't do that. We had a dew point of 6, which gave us a dry bulb of 8. So you should have come down to 1 and 8 here, which got you 87. And that is totally something they would do to you on the Regents. Now this one, they want to know the dew point. They tell you the depression is 6, the relative humidity is 61. So again, the difference is 6. What was the relative humidity? 61. So 6, you go down till you find 61, which is right here. So that means we have a dry bulb of 30, a difference of 6. Difference of 6, dry bulb of 30, I got 21. And then question 5 is the exact type of question the Regents would do because they love to mess with you. So they tell you a student uses a sling psychrometer, just like you guys have been in lab, to measure the humidity. They figured out that the relative humidity was 65. They figured out the dry bulb was 10. They want to know the wet bulb. So we work with what they give you. Again, they give you a humidity and a dry bulb. So they give me a humidity, so I know I have to use the humidity chart. They give me a dry bulb of 10. If I have a dry bulb of 10 and a humidity of 65, that tells me the difference is 3. So do I just circle 3? No, what does the question ask? They want the wet bulb. So that is 10 minus the wet bulb equals 3. That's answer 7. See how they gave you that, like the wrong answer, but the one that you all would have seen? Everybody would have seen that 3 at one point because that was the difference. They count on you screwing up like that. They are jerks, but you have to get used to them being a jerk. Okay. All right, then the next page, 37. I'm going to tell you right now, all the answers were decreasing. So anytime you had an increase line, it's wrong. And now we're going to go through why. So the reasons are important here. And I'm going to tell you, you got to be able to do this or understand all of these relationships for this chapter. So let's start with as temperature increases. So as it gets warmer, what happens to pressure? And guys, I have gone through this a dozen times, if not more with you. What does warm air do? Well, actually, let me go back. Put high pressure on your desk right now. Okay, you're pushing as hard as you can, not high pressure. So now if I tell you to put less pressure, what do you actually do with your hands when you put less pressure on the desk? You lift up a little bit. So if you're putting a lot of pressure, that's high pressure. If you're putting less pressure, you're pretty much lifting up with your hands. So air pressure works the same way. When does the air push down with all its might? Not when it's hot.
Oh, cold.
Why when it's cold?
Because the molecules push together.
And that makes them
More dense.
more dense. Okay, so let me rephrase this so in case you didn't catch what Justin just said. Think of a hot air balloon. When would a hot air balloon push down on the ground? Or when would it go down? When there's no heat, when it's colder. Cold air sinks. So cold air is the one pushing down. Once it warms up, it begins to lift up. So here he says temperature increases. So when temperature increases, when you increase the temperature in a hot air balloon, what's the balloon do?
Goes up.
Goes up. Hot air balloons. Hey, you good with this? Hot air balloons rise because why? They're less dense. So as temperature increases, so we're warming it up. If we're warming up the air, is it pushing down or lifting up? Lifting up. And if it's just like my hands, when I'm lifting up, am I putting more pressure or less pressure? Less. So warm air rises. And when warm air is rising, it's not pushing down. Down. So when warm air rises, it's not pushing down. So it's not high pressure. So as we increase temperature, air pressure decreases. How do I draw that? First of all, what goes on the X? Okay, it's always the thing that said first. So you could have done that for all of these. It's always what's said first. So temperature, pressure, and decrease as it goes down line. I can't move that. The projector's in the same spot. Let me move this. Oh, sometimes technology makes me seem dumb. So let's figure out why this next one is a decrease. Who did lab this morning or yesterday morning even? Riley, do you remember what the humidity was outside when you did it yesterday? No. Does anybody remember what their humidity was yesterday or this morning? No, outside. It shouldn't have been.
43.
No, it shouldn't have been. Yeah, not, I'm sorry, yesterday morning. Might have been different for you.
Yeah, no, I didn't have that. I'm just guessing.
Oh, no. Yeah, the humidity. Let's talk about this, guys. Actually, let's all talk about this. So even if you didn't do lab in the morning, guys and girls and people, what's on the grass this morning?
Dew.
Was it dew this morning?
Frost.
It's frost this morning. But just to clear this up, what's frost? Frozen dew. Okay. So frost is just frozen dew. So it's dew that gets frozen because it's cold out. Was there frost on the grass this morning?
Yeah.
There
I
was.
actually walked through it.
Yeah, and a little crunchy, right? Yep. And those of you who went and did your slings, no, that wasn't your class. What was the humidity for you outside? Do you remember? It was like 100. Not, okay, so that we learned yesterday means it's supposed to rain. What else does it mean? What does it mean if this jug was filled up 100%?
No more video.
No more can go in. So where does it go? Out. So if I'm trying to pour it in, it's going to end up on the ground, right? So if the air, the relative humidity this morning was 100%, so where does the rest of the water go?
No.
Out.
But why didn't it?
It did.
Oh, it did?
What was it this morning?
Oh, frost.
Frost.
Makes sense.
Guys, dew happens when the air can't hold any more water because it's already filled up. It's already filled up. It can't hold more. So water droplets form.
What about fog?
Fog's the same deal. The airs are legit. You can see it with fog. Fog, the air is so full of humidity. You see fog in front of you. There's so much water already there, it can't hold anymore. So the water droplets form in the form of fog.
That's here it is.
Same with when it's raining.
What about
What? Same with when it's raining. The air is so filled, you can see the water droplets in front of your face in the form of raindrops and snow. The air is so full of water, more can't go in it. So you see the snowflakes in front of your face. So this morning, when Calvin went out and did the relative humidity, the relative humidity was 100%, and I double checked, I touched the grass, and it was still wet. So guys, let's talk about this. When relative temperature increases, so relative humidity right now, it says 61%.
No.
So we don't even have to go out and do it, 61% right now. So what's not on the grass right now?
Dew.
There's no dew on the grass. So let's talk about that. How is there dew this morning or frost this morning, but not frost right now? Or dew?
Evaporation.
Yes, but why is there still not any forming out there?
The heat is up.
What heated up? The temperature heated up. This morning, guys, it was cold. How much water can cold air hold? Not a lot. That's all I'm looking for. Cold air can't hold a lot of water. So when it's cold, the water comes out. So this morning, the air looked like this jug. It was a little jug. Can't hold much water. Right now, what kind of jug does it look like now? Bigger jug. Right now, it's a bigger jug. So if this jug was full this morning, does it fill this jug? This was full of water. Is that jug now full 100%? No. There's still water in there. Maybe like 20%. I don't know. I can't do the math that quickly, but when the air is full, when it's cold, 100%, it does not mean 100% when it's warm. So this morning and today, we increased the temperature. It was really cold this morning. Well, it wasn't really cold, but it's 32 this morning. Now it's 42. Increase the temperature. What happens to the relative humidity?
Goes down.
Goes down. 60 something now. What was it? 61, 68 something?
61.
61% humidity. So that full jug of cold air does not equal a full jug of warm air. So, the key words here is cold air and cold, less water.
Did you know the sunrise and the sun sets 12 hours and 6 minutes apart from each other today?
That's weird. Side note. Man, getting me off topic, but staying on topic. So why was that weird to you?
I don't know.
Like, why did you feel the need to announce that to us?
Because they're just so in line.
They are so in line. Guys, does anybody know what's today's date?
Solstice.
Today is the 15th. Does anybody, whoa, is it a week from today?
Lunar.
20th, 21st?
North shadow.
No, you guys already said it. Somebody said it.
Solstice.
The solstice. Do you guys know what the spring solstice, actually, it's not the solstice. Why am I listening to you? It's called the spring equinox. Does anybody know the normal term for the spring equinox?
No. The sun sets.
The first day of spring. But why do you think it's called the equinox? Or one reason it's called the equinox.
Equal.
Because we have equal amounts of daylight. So when Jake looks at that next week, he's gonna go, wow, the sun rises exactly 12 hours after it sets. You can go ahead, take a nap, take a nap. Watch this video online. So how do we show this on the map, on the graph? Temperature. Relative humidity, decrease. When the air is cold, it will be 100% filled up with water. But that 100% is not, that goes down when we warm up the water. I don't. Huh. Holy cow, I hope you guys got this next one right because I've been beating it into you. As temperature increases, so it warms up. Density decreases. Why does a hot air balloon rise? Because it's less dense. Why does warm air rise? Because it's less dense. Warm air is, why, by the way, is it less dense? Because molecules expand, they spread out. Hot, sweaty molecules don't want to be next to other hot, sweaty molecules. Warm air is less. It's really less dense. Warm air is less dense because molecules expand or spread out, however you want to word that. Thank you, Renee. But less kind of sounds like less dense. Now, you could have gotten the answer to the next one off of your ESRT page 14. I did tell you that, and honestly, that would have been a good explanation. Oop, went the wrong way. Page 14 right there tells us as we get higher in the atmosphere, what happens to the water vapor? So it starts on the ground at 40, goes up to 0. Now that's one way. So it does decrease. Like I already said, they're all decrease. But we really want to know why. So let's talk about this. What happens to the air as it goes up? No. Guys, what happens?
It gets warmer.
No. What happens when you walk up a mountain?
It's colder.
Gets colder. Okay. But let's talk about why it gets colder. What do those hot, sweaty molecules that are rising do? No, when they're rising, what do they do? Or why are they rising? So why are the hot, sweaty molecules? They're less dense. They're spread out. And what happens to those spread out molecules once they're spread out? They cool down. So as warm air rises, it cools. We learned that yesterday. Adiabatic cooling. Adiabatic cooling. As warm air rises, it cools because they're spread out and they cool down. So as the air cools down, what do we know about air that cools down? When it goes from being warm, yeah, cold air can't hold as much water as warm air. So the reason this one decreases as air rises, it cools. Cool air can't hold as much water. I'm going to abbreviate water H2O because I'm out of space. And we literally just answered the next one. As altitude increases in just the troposphere, what happens to temperature? So as that air goes up, the warm air is rising. What do the molecules do? Because warm air is rising, it decreases, but as warm air is rising, what happens to the molecules? They expand, and because they're expanded, they cool off. The temperature decreases. Or again, you could have gotten that out of your reference table. But it says as, and that this one up here, as air rises. As air rises, it cools. Why does it cool? Because molecules spread out. And let's just get this next one. Could be a picture or from your reference table. Remember, the definition of air pressure is the amount that the air is pushing down on you. When you go up, how much air is on top of you? Not too much. So this is because as you go up, there is less air to push down. Guys, there was a theme on this whole entire sheet. Yes, they all decrease. That's not the theme I'm talking about. What were some key points that you have to know to basically answer all of these? And because, so you need to know warm air rises because it's less dense. What happens to that warm air as it's rising? It expands and it gets cold. So air cools as it's rising. And then how can we add pressure to all of this? Let's do this. Cold air. That says cold if you can't read that. What kind of pressure does cold air have? High pressure. What kind? Sorry, I'm running out of space. And warm air has what kind of pressure? Low. To answer all of those, it all came back to those points. Warm air rises because it's less dense. Air cools as it's rising. Cold air is high pressure. Warm air is low pressure. You must get those concepts. Then you can answer all of those questions. So that what says warm air rising because it's less dense. Underneath it, it says air cools as it's rising. And then off to the side here, cold air, high pressure, warm air, low pressure. Those are the concepts that you just must have. And I don't have much more to do to make sure. You just have to know that. All right, we don't have too much more time, and I realize we've been skipping over wind every day. So we're gonna go to wind, page 27, sorry. We're going to start with these two pictures, which you have both of these pictures and you have them both labeled right there on the top of page 27. So I don't know if you remember, I said this last week. Every Regents I've ever seen has one question that says, here's a weather instrument, thermometer, barometer, sling psychrometer, or these guys. So every Regents will always have a weather instrument. You need to know the names of them. So thermometer, barometer, sling psychrometer, anemometer, and a wind vane. And you need to know what those instruments do. Temperature, measures temperature, I mean. Thermometer measures, no. Temperature measures Oh my gosh. Thermometer measures temperature. Barometer measures pressure. Sling psychrometer can be used to determine dew point and relative humidity. What about a wind vane? Yeah, which way the wind's blowing. So we need to add that to your picture here. I don't have it on the actual PowerPoint, so let's do wind vane. You got room underneath it. Shows wind direction. You guys have probably seen a wind vane in your life a time or two. Typically, they are like they do sometimes look like this, where they just have little arrows on them. I see a lot of them have like roosters on them. My in-laws have one that has a pig on it. But in the end, it just shows you, it's got the arrows on it to show you which way the wind's blowing. Can you figure this guy out? It's got little cups, an anemometer's got little cups instead of just direct arrows. Yeah, this one's gonna measure wind speed. So those little cups, there's a little counter on them that shows how many times the cups go around, and then it'll measure the wind speed. So again, you need to know that an anemometer measures wind speed and a wind vane shows wind direction. Have you guys ever heard the phrase passing wind?
Like farting.
Like farting. Yeah, that's what I meant. So yeah, it's my grandma, she never said fart, but she would say passing wind. A toot, yes. But we've talked about farts in here already. So let's do a quick review of farts. Which way do farts blow?
I'm saying that word.
Farts?
Inky, a flatulent.
What's going on with farts? Were
I
you taught not to say farts?
I like that word, but like it's just right now it's really making me.
Do you have to fart?
No, I
Oh,
didn't.
okay.
Call it an eight.
Okay, tooting.
Eight.
I prefer farts.
Okay, then say fart.
Okay, I mean, I am in charge of the class.
Say eight.
So farts always blow from,
Back.
well, from your butt, yes. But in terms of what I want to talk about, let's talk about pressure. They go from your butt, which has what kind of pressure?
A lot.
A lot of pressure, to the air that has less pressure. Farts always go from high to low pressure. I could be less disgusting. And last year you learned about osmosis and diffusion, right? Remember those words? Remember which way they always flowed across the cell membrane?
Mr. Clinic, we always have demonstrated with a beekeeper and diffusion.
Okay, well, that sounds less disgusting, but I don't want to talk about it. Do you remember they always went from high concentrations to areas of low concentration. So if you really don't want to talk about farts, think about that. But I want to talk about farts. Farts always blow from high to low pressure. And the reason I brought up the passing wind is because, what do you think? Nobody can make the connection. Am I just like up here talking?
Yeah.
Passing wind, and we're on to the wind chapter right now. Which way do you think wind blows? Well, so which way do you think winds always blow?
Any way it wants to.
Relate this to farting, please. I don't.
Out.
Wind always blow from areas of high pressure to low pressure, which we just talked about. High pressure, cold air, warm air, low pressure. So it's truly wind is caused by an uneven heating of Earth's surface. It's basically nature's way of sharing the wealth. Warm over here, cold over there. Let's share the wealth and mix them together. So this goes on all the lines there on page 27. You guys picture a really windy day? I know we had one a couple days ago. Last week, we got super windy one. You picture the weather like the day before and the day after? Or before the wind and then after the wind?
Can I picture the what?
The weather.
Yeah, it's a little cold. Cold
When?
after, dirty.
Okay. Typically windy days happen when there's a gorgeous day and then a very yucky day, or vice versa. A yucky day and then a gorgeous day.
So the wind's blowing from the yucky day into the gorgeous day.
Yeah. Because wind blows from high pressure to low pressure. I had to stop and think, see if he was right. High pressure to low pressure. High pressure happens with what kind of temperature?
Good, bad.
Well, okay, let's stop and think here. In fact, we're going to write this down again. High pressure. You can't. Is what kind of what temperature? Cold. Again, because cold air sinks. Low pressure is warm air because warm air rises. So if the wind always goes from high pressure to low pressure, it's going from the cold air to the warm air. So the stronger the wind happens when there's a bigger pressure difference or a bigger temperature difference is the same way of saying that because temperature controls pressure. And then there's one more thing. Closer the isobars, the stronger the wind. So add that as your next bullet. Isobars, we talked about that so long ago. What's an isobar? You don't. ISO lines, any ISO lines. What are ISO? Oh my gosh, we just did this last week. Remember those? Lines that connect areas of equal pressure. So when, no, it was literally last week, but that's okay. And we did it a while ago, but we did it last week too. Okay, but we talked about when the lines were closer together. Do you guys, who remembers that? When this was a map of a hill, not just height, we did height, the lines connected areas of equal elevation. But what did it mean when the lines were close together, like up here? It was steeper.
So it's pressure now.
So now instead of being steepness of a hill, it's the pressure change. So how steep the pressure change is. If it's a steep change, it means it changes really fast. If it's a gentle change, it means it happens really gradually. So up here, the pressure change is really great. It changes pressure really quick. And because the difference, the greater the difference, the stronger the wind, here's where the difference happens the most. Like it happens, the change happens really quickly versus over here, it changes very gradually. So up here is where we're going to have the stronger winds. All right, that's the last thing for today, and you have no homework.
Yes.
I think, yeah,